how sensitive the climate system is and what the consequences are going to be. For example, yeah, it's true. This is a graph of the temperature, actually the temperature in the deep ocean over the last 65 million years, the Cenozoic era, beginning after the dinosaurs had disappeared. And during the first 30 million years of that period, the planet was so warm there was no ice on the planet, no ice sheets on Antarctica or Greenland. And we know why that was. Changes in the Earth's temperature have to be due either to the amount of energy coming in, or to some changes on the surface, or to some changes within the atmosphere. But we know how the energy coming in changed. The sun is a well-behaved main sequence star, which is burning hydrogen to make helium in the core with nuclear fusion. And it's slowly getting brighter. So 65 million years ago, it was about 0.4% dimmer. Since the Earth absorbs 240 watts of energy from the sun, that means that there was 1 watt per meter squared less heating of the Earth. And it's slowly increasing over that 65 million years. We know that the continents were not quite in their present positions 65 million years ago, but they were already at about the same latitudes that they are today. So the changes on the surface amount to a forcing only of the order of 1 watt per meter squared. But we know that the carbon dioxide in the atmosphere changed from as small as 170 parts per million to more than 1,000 parts per million. That variation in CO2 is a forcing of more than 10 watts per meter squared. So that is clearly the major cause of the climate changes over that time period. And as the carbon dioxide, it was, and we also know the reason, by the way, why that happened. The amount of carbon dioxide in the atmosphere is determined by the balance between the source of CO2 to the atmosphere, which is volcanoes, and the sink of CO2, which is the weathering process. As the rivers carry sediments to the ocean, the chemical reactions associated with that deposit carbonate sediments on the ocean floor, taking CO2 out of the atmosphere. But the source and the sink at any given time are not necessarily in balance. They depend upon continental drift. The volcanoes occur at the edges of the continents that are moving. And as the continents move and subduct ocean crust beneath them, that metamorphosis of the high pressure and temperature beneath these moving continents converts those ocean sediments into heavier rocks, and in the process emits carbon dioxide through the volcanoes and the springs. But that depends upon where the continents are moving. And in the case 65 million years ago, the one main change was that India was still south of the equator, but it was moving north rapidly at a rate of about 20 centimeters per year. And it was plowing through this Indian Ocean, which had long been the depot center for major rivers of the world. So it was subducting this ocean crust and producing a lot of CO2. And that is why the planet was getting warmer and warmer until India crashed into Asia and began to push up the Himalaya mountains and the Tibetan plateau. And the weathering of those mountains then became a sink for CO2, and the source was diminished once India had reached Asia. And so the planet, as CO2 started decreasing, and the planet cooled off. So the bottom line is that, yeah, the natural processes can cause huge climate changes. At the 50 million years ago, when the planet was much warmer, there were crocodiles in Alaska. It was a much warmer planet. So the these imbalances between the volcanoes and the sink amount to of the order of 1/10,000th of a part per million of CO2 per year. So in a million years, that makes a change of 100 ppm in the CO2. But humans now are increasing CO2 at a rate of 2 ppm per year. So we're now 10,000 times more powerful than the natural geologic changes in atmospheric CO2. So we are in control of future climate. Natural changes are completely overwhelmed by the human-made change from now on. And it also shows us how sensitive the climate is, because at the time Antarctica began to form ice sheets, there was only about 450 or maybe 500 parts per million of CO2 in the atmosphere. So if we burned all the fossil fuels, we would be sending the planet back to the ice-free state. It would take a while to get there. The ice sheets don't melt instantly, but we would have a situation which, as the ice sheets did begin to disintegrate, would be out of control of the people, the young people who will be around when that process starts. So another question that I am asked is, why do I advocate use of nuclear power? And this is the last personal question, then some other people can ask questions. But what I say is that the highest priority needs to be on energy efficiency, and secondly, on renewable energies, and only thirdly, on the potential for nuclear power, and then fourthly, on carbon capture and sequestration. Frankly, there is no such thing as clean coal, and this carbon capture has been used mainly to divert attention from the continued use of coal. But carbon capture is actually a useful technology, because in order to draw down the amount of CO2 in the atmosphere, we can burn biofuels in power plants, capture the CO2 and put that underground and draw down atmospheric CO2. The thing that I wanted to say about nuclear power is that the potential is in the combination of third generation and fourth generation nuclear power. The nuclear power that is used now is second generation nuclear power. These are light water reactors that use water to slow down the neutrons. Those power plants use less than 1% of the energy in the nuclear fuel, the uranium. And third generation is still a light water reactor, but it's safer. It's the kind that will shut down automatically if there's an anomaly, for example, instead of requiring humans to turn it off. So if there's an earthquake or something else, you won't get a disaster. Fourth generation allows the neutrons to move faster, so it can burn all of the nuclear fuel, and not more than 99%. So it's more than 100 times more efficient than third generation. And furthermore, it can burn nuclear waste. And so it can solve, it's our best potential solution for the nuclear waste problem. And the thing is, you have to understand, all the evidence that we have, I would be happy to convince otherwise, but all the evidence indicates renewable energies are not going to be enough to provide the world's energies. Certainly not for China and India. Sun and wind are not going to provide all the energy that they need. And even if you look at the greenest countries, say Germany, which has devoted a huge amount of money to renewable energies, to encourage, they're subsidizing wind and solar energy to a high degree, so high that many industries are starting to move out of Germany because the electricity prices have become so much higher. And how much of their electricity are they getting from these renewables? Well, now it's 7% averaged over the year. In the middle of the winter, when the wind is blowing strong, they get more than that. But averaged over the year, it's 7%. Maybe they will double or triple that. But so what are they planning to do? The government is planning to build 20 more coal-fired power plants. So the empirical evidence does not suggest that renewables can do the whole job. And the best way, nuclear power is not going away. There are more. China is now building 24 nuclear power plants, and if we want to minimize the danger of weapons-grade material getting in the hands of people, we should have control of the technologies. So it was a bad decision of the Clinton-Gore administration in 1994, just when the experts at Argonne National Laboratory said they had all the elements now to make a fourth-generation nuclear power plant. Then the anti-nuclear people who support the Democratic Party convinced the Clinton-Gore administration to terminate that, because the anti-nuclear people were afraid, oh, we're not going to be able to shut down all the nuclear. Well, we're not going to be able to shut down all the nuclear anyhow. So the United States really should have tried to be on top of that technology so that you can have the international agreements and ways to minimize the danger of nuclear power, rather than sticking our heads in the sand and allowing, because there, as far as fourth generation is concerned, there are 6 other countries that already have the technology. So we're not going to wipe it out by stopping it ourselves. And by the way, the nuclear power has the best safety record of any major industry. In the United States, there was an accident, a 3 Mile Island accident, which released radiation to the atmosphere. And the best calculations for the effect of that suggest that there will be about 1 death, one cancer death, in addition to the several thousand that the people in that region would have had without that release. The exposure to radiation was equivalent to flying back and forth across the country at the altitude that airplanes fly, 2 trips. So, as I say, nuclear can be made safer. So I think it should be on the table. But yet I get these messages all the time, and people are very, they're very not angry messages, people who are very disappointed in me because I say that we have to look at the nuclear option. But as a scientist, it's not my job to say what people want to hear. And it's my job, I think, is to be as objective as I can. But in contrast, this is a graph showing different types of energy in the United States. And it's a graph which Amory Lovins had made in the 1970s. Now, Amory Lovins says that we do not need nuclear power, we do not need coal, we do not need oil, we do not need gas, and we do not need large hydroelectric dams. That we can do everything with energy efficiency and soft renewable energies. That is exactly what everybody wants to hear, and every month Amory gets another award. But the fact is, now, and he gets a lot of credit, and by the way, one other thing, he says you do not need taxes on carbon. Now, and he was right about energy efficiency. He said that the governments were wrong who say that we have to keep using more and more energy at an exponential rate. In fact, energy use in the US has been fairly flat. It's increased, but not nearly at the rate that the government predicted. But the soft energy, renewable energies are still invisible on this graph. 30 years later, you cannot see them. There is a renewable portion, but that renewable portion is large hydropower and some burning of biomass. The dream that soft technologies, and we don't need any of those fossil fuels or nuclear power, the empirical evidence simply does not support that. So it would be nice to tell people what they want to hear, but that's not what the evidence. And I think, you know, if you're making the decision that I will not allow the consideration of nuclear power, I think you need to think about your children and the other species on the planet. And one reason that India and China are planning to go mainly nuclear for their electric power is that they want to clean up their atmosphere and their water. And that